In this lesson, we are going to learn how to count chemicals in the unit of moles. Now, why do we need the unit mole when we count chemicals? Well, think about it. When we go to the grocery store like Costco and we want to buy 60 eggs, we don't go tell them, I want 60 eggs. That means they have to punch in 60. Now, what if you are a business person and you are talking about 1,000 of eggs? So we use the unit dozen. So when you go to Costco, you're looking for a dozen of eggs. That tells you there are 12 eggs. So that's the reason why we have different units to represent different values. So if I say if I want 24 eggs, I would say I want 2 dozen of eggs. That tells you there are 2 of 12 eggs. Okay? Because this 12 represents dozens. And if I want 6 dozen of eggs, what is 6 times 12? Well, in this case, let's rewrite this. 6 of 12 eggs. There you go. Because that doesn't mean 12. So 6 times 12, let's use a calculator just to prove it to you. That tells you when you buy 6 dozen eggs, you actually buy 72 eggs. So this equal to 24 eggs, and this equal to 72 eggs. Now do you see why we use unit to measure small substance? Because it's a lot easier for us to calculate in the calculator where we have to deal with smaller numbers, so less chance of making mistakes. What about atoms? Well, atoms are very tiny and they are invisible to us, right? But we can actually count them in terms of the unit mole. So when we count atoms, ions, molecules, and formula units, we use the term mole. And what is a mole equal to? Remember the Avogadro number? That mole is equal to 6.02 times 10 to the 23rd. So instead of being 12 line dozen, a mole equal to that big number, okay? So we have 1 moles of copper. That tells you we have 1 of 6.02 times 10 to the 23rd of copper. There you go. Now, we have 3 moles of copper. That tells you there are 3 of 6.02 times 10 to the 23rd. Because that number right there is a mole. Okay? So keep that in mind as you use the unit mole. Now let's look at a chemical formula to determine how many moles of each element or substance are in a chemical formula. Well, if we look at this, there is a number right here, right? Look how this number is in front. Just like in your math class, when we have a number in front of a parenthesis, that tells you how many there are in here. To think of that number like that one. And this number has a name. It's called coefficient. So this is a coefficient, okay? And the coefficient number is in front of a chemical formula. So this whole entire thing right here, okay, is a chemical formula. Okay? So this is the chemical formula. This is the coefficient. Well, the coefficient number in front of a chemical formula show how many of the substance. In this case, that is a 3. So tell you there are 3 of Ca parenthesis NO3 2. Okay? So there are 3 of this chemical formula, or 3 of this substance. Where this right here, the letter S and in parenthesis, that tell you that is the state of matter. Such as in solid for S, right? L for liquid, and G for gas, and sometimes AQ for aqueous. So keep that in mind. This is the states of matter. Then we also have this little number right after some elements. Well, right here we have 3 and 2. And that 2 is outside a parenthesis. So there are 2 locations that this number can be. right after an element, or it could be after a parentheses. And this little number are called subscript. Think of the subway, right? So how the subway is going underground. So if we draw this out, that is called the subscript. Okay? So the subscript after an element, such as in O3 right here, see how the 3 is after O right there? It shows how many of that elements. So in this case, see how the 3 is in O3 right here? It tells you there are 3 of oxygen. If we have the subscript number after the parenthesis, like in this case, such as a 2 right there, that number 2 right there show how many of this whole entire thing. And this thing is grouped as a polyatomic ion, so we can say that it tell you or show you how many of the ions in the parentheses or grouped in the parentheses. Okay, so keep that in mind. That tells you there are 2 of NO3. So let's apply this problem. Well, first of all, determine how many moles of the substance. Well, that's easy. This whole entire thing is a substance, and that 3 right there tell you there are 3 of that substance. So in this case, there are 3 moles of CaNO3. 2. Isn't that easy? Next, we are going to determine how many moles of each element in this chemical formula. When we look at this, we have 3, right? CaNO3, and then it's 2. We don't care about the states of matter for now. Now, if we look at the chemical formula only, and ignoring the 3 for now, we can say that calcium, okay, has 1. But since there are 3 of the whole entire substance, we can take that and multiply by 3. That gives us 3 calcium. What about for nitrogen? Well, look at calcium and nitrogen. Do they have a subscript like in O3? No. When there is no subscript, that tells you there is a number 1. Just the same thing later on when we look at this. When there is no coefficient, we assume there is a 1. Okay? Because anything multiplied by 1 is equal to itself. So in this case, we have nitrogen. But look at this right here. That nitrogen is in the parentheses, and outside there are a number 2. And that number 2, again, think of math where we have a number outside a parentheses, right? We have to distribute it in. But in this case, we're using the subscript outside because that 2 right there tell you there are 2 of this. So we distribute it from this end. So in this case, 2 times 1, that gives you 2. So for nitrogen, there are 2 of the nitrogen because of that 2 right there. And then, since there are 3 of the whole entire substance, we multiply by 3, that gives us 6 nitrogen total. What about for the oxygen? Well, for the oxygen, look at the 2 right there. That tells you there are 2 of O3. So what's 2 of O3? Of course, 6, right? Or you can say 2 times 3 if you're using math way. But 2 of 3 right here, that tells you there are 6. But we have 3 of the whole entire thing, so we multiply by 3, that gives us 18 oxygen. Isn't that easy? Let's try another one. In this case, we have this chemical formula right here, and this coefficient 2, and we have multiple subscript, right? Determine how many moles of a substance. Well, that 2 right there tell you there are 2 of this whole entire substance. So we have 2 moles of Al2CO3, 3. Okay? Isn't that easy? Because of that coefficient right there. Now determine how many moles of each element. Again, we are gonna rewrite this so we can interpret very carefully CO3 and 3. And again, that right there is a coefficient. But before we look at the coefficient, we should focus on that chemical formula itself. Focus on the substance first. Well, let's look at aluminum. Okay, Aluminum has a subscript of 2, that little number is subscript right there. So that tells you there are 2 aluminum. But there are 2 of the substance. So we multiply by 2, that gives us a total of 4. So that 2 is right there. And that 2 is right here. Okay? Then let's get to carbon. Look how this ions is grouped by this parenthesis, right? But this 3 outside the parenthesis tell us there are 3 of that right there. So there are 3 of CO3. Okay, so keep that in mind. That's what that 3 tell you. So if there are 3 of C, what does that tell you? So carbon must have 3, but there are 2 of the whole entire substance, so we multiply by 2, give us 6. Let's get to oxygen. Well, for oxygen, there are 3 of O3. What does that mean, 3 of 3? So that tells you there are 9 total, right? So we take 3 times 3, just like we take 3 times 1, if we're using the mathematical term. So therefore, we have 9 of oxygen, but there are 2 of the whole entire substance. So we multiply by 2, that gives us 18. And of course, we use the unit moles, okay? So 4 moles of Al, 6 moles of C, 18 moles of O, okay? Isn't that easy? And the same thing in this case when we do this right here as well. This is mole of Ca, this is 6 moles of M, and this is 18 mole of oxygen. So keep that in mind. We're using the unit mole. Let's try another problem. Here we have this chemical formula right here, and it asks you how many moles of a substance. Well, of course, that coefficient right there tells you there are 5 moles of BaSO4. Okay, and this is a solid. And again, we determine how many moles of each element. So we're going to rewrite again 5BaSO4. And of course, we're going to focus on one substance. This tells you there are 5 moles of the substance. So let's look at this. How many moles of each element? So in this case, Ba, barium, doesn't have any subscript, so we assume that's going to be 1 right there. So of course tell you there's 1, but we have 5 of the substance, so we have to multiply by 5. So that gives us a total of 5 moles of barium. Let's look at sulfur. Sulfur, no subscript again, so that tells you there are 1 only, and 1 multiplied by 5 because there are 5 of the substance, because that's the coefficient right there, give us 5 moles of sulfur. Then oxygen, okay? Oxygen, that subscript tell you there are 4 of oxygen. So in this case, there are 5 of the substance, so we multiply by 5. That gives us 20 moles of oxygen. Isn't that easy? Now let's try something more complicated, okay? Notice how we have like 2 chemical formula in one. Because here we have a chemical formula for water right here, isn't it? And then we have another chemical formula for this substance. But this whole entire thing actually one substance. Basically, this is called a hydrate. Now, what is a hydrate? A hydrate is basically when you have an ionic compound surrounded by water molecules. A specific number of water molecules. In this case, there are 5 water molecules, okay? Well, to make this a lot easier, I remove the coefficient, okay? Well, let's look at this chemical formula. How many moles of the substance do we have? There are no coefficient here, so we can tell that there is only 1 mole of that whole entire thing, CuSO4 5H2O. See that dot right there? That dot is like a multiplication sign in math, isn't it? So basically, this is being surrounded by 5 water molecules. Now let's determine how many moles of each element. To do that, we need to realize, oh, do we need to rewrite again? No, we don't have to. Let's look at this. We have copper, we have no subscript right there, so copper, that tells you just 1. And do we have to multiply by any? No, because there's only 1 as a coefficient. And then sulfur, we have no subscript, so that tells you just 1. Let's look at oxygen, okay? Look at oxygen. We have 4 right here, okay? But there's also oxygen here. What's the subscript for oxygen here? It's nothing there. So we assume it's going to be 1. But how many water molecules do we have? We have 5. So that tells you we need to add 1. Well, we can think of this way. 1, but that 1 is being multiplied by 5 because there are 5 water molecules. So that gives us a total of 9 oxygen total. Isn't that a little bit tricky? Then we have hydrogen. Well, we don't have any hydrogen here, but we have here. There are 2 hydrogen because of that subscript right there, but there are 5 of them, 5 of water molecules, so we have to multiply by 5. That gave us 10. So we have 1 moles of copper, and then we have 1 moles of sulfur, then we have 9 moles of oxygen, then lastly we have 10 moles of hydrogen. Isn't that easy? Let's try another problem. Here we have the same problem as above. Well, in this case, the number of water molecules changed. But let's go back and determine how many moles of a substance. The whole entire substance is this one. That number must be 1 because anything multiplied by 1 equals to itself. So how many moles of the substance? Of course, it'd just be 1 mole of the whole entire substance. MgSO4 with a little dot right there multiplied by 7 water molecules. So again, this is called a hydrate. Think of hydrated water, okay? So how many moles of each element? Let's go back. Of course, magnesium is just gonna be 1 because the subscript right here is nothing there. It's just 1. Sulfur is also just 1 because there's no subscript. So we assume it's gonna be 1. Then let's get to the oxygen where it gets tricky, right? Where in this case, it's gonna be 4 in here, but there is also oxygen here. That tells you there's 1 right there, so we need to add that together, 1. But there are 7 of the water molecules. We have to multiply that by 7. Give us a total of 11 oxygen. Now let's get to the hydrogen. Well, the hydrogen, there are 2 right there, based on that subscript, but there are 7 of the whole entire water molecule. So we have to multiply by 7. That gives us 14. So isn't that easy? And then we are done.